My first question to myself is, what is it? You already, yes, you already passed that because you answered correctly. That will be the next step. True. So this is an exponential equation. Perfect. So yes, my next question to myself is, can I make this base and this base look the same?
Yes.
And the answer is no. 2 and 3 cannot be presented with the same base. They're both prime numbers. There is nothing I can do. I cannot change the base.
No.
On an exponential, I cannot change the base. I wish I could. So then what can be done? If the two sides don't have the same base, what should I do? What is the only option? Not Tom. Say it again. Somebody said something. If I cannot present left-hand side and right-hand side with the same base, there is an option. What is the option? So what do we do in this situation? There is a way. Nope. Yes. Yes. I know. I just apply the same log to both sides because log is the only function that allows us to bring the power in front and make this equation into a linear equation. I have to write x minus 2 in parentheses and then natural log 2. I have to write 3x plus 5 in parentheses multiplied by natural log 3. So I have to use the inverse function. The inverse function of the exponential is log. Does it matter if I use ln, natural log, or log, common log? No, as long as I apply the same one to both sides. Good. So I did use the property, the power rule, that allows me to bring the power in front as a factor, which means that I have to show that this is multiplying natural log 2. I have to show that this is multiplying natural log 2. That's why if I omit parentheses, the problem is done. I can never solve it. So what will be the next step? Any suggestions? I'm trying to solve for x. What will be the next step? I have to distribute natural log. X natural log 2 minus 2 natural log 2 equals 3x natural log 3 plus 5 natural log 3. Next step. Yes. However, since I'm solving for x and I have these two terms with x, one on one side and one on the other, and I have these two terms without x, what will be my next step? It's a linear equation. How do I solve it?
All the x terms on one side.
Yes, very good. So I have to move this term here and this term here. Let's do that. X natural log 2 minus 3x natural log 3 equals 2 natural log 2 plus 5 natural log 3. Very good. Now what? What would I normally do in such a situation? I would combine like terms. They are not like terms. So when I cannot combine them because they are not like terms and I am solving for x, what is the next idea or step?
Divide them.
Cannot never divide them. What are the keywords in this class? Say it again. I can't. I'm not condensing the logs with expressions in front. What are the two keywords in this class and in any math class? Yes and correct. So let's think of those and tell me which one will work here.
X.
Yes, which means which keyword did you use?
Factor x.
That's it. I have to factor out the common factor of the terms on the left. Perfect. So then I have natural log 2 minus 3 natural log 3, and the right-hand side is 2 natural log 2 plus 5 natural log 3. If you go back when you study for this test and you go back, you will see problems like this one from the book. And then finally x, what do I have to do to both sides? By this, whatever number multiplies x. Very good, awesome. So 2 natural log 2 plus 5 natural log 3, natural log 2 minus 3 natural log 3. Do not attempt to simplify anything. Nothing is simplifiable here. Yes, you can punch it in the graphing calculator. You can check. You can go back and check and punch it in here and see if you get the same answer.
You really don't need a calculator for that.
Absolutely, you need to. Yeah. Okay. Any questions on this problem? Please practice it as many times as you need.
This was the first step that you did. Was
Yes?
The first step.
Yes.
Like,
The first step was I was asking myself, what is it?
okay.
Because if I am not able to identify it correctly, chances are that I won't be able to solve it correctly. So that's my first thought. What is it? Ooh, I see the variable is at the exponent level, so it must be an exponential equation. That was my first thought.
Okay.
My second thought is, can I present both sides with the same base? No. 2 and 3 are prime numbers. There is nothing I can do. If I had a 4 and an 8, yes. If I had a 27 and 9, yes. But 2 and 3, I'm done. Can't do anything. So then my next thought was, well, I have to do something to both sides, the same thing, whatever it is, but it has to be done to both sides. And somehow what I'm doing to both sides should allow me to put the power in front and change it into a linear equation. And that mechanism is obtained only by applying the same log to both sides. Because log is the only function that has 3 properties, and one of them is that one. That allows me to bring the power in front as a factor. And that's what I wanted.
So when you take the log of an exponential.
When I apply log to both sides, the power becomes a factor in front. That's one of the 3 properties.
I got you. Okay.
The other 2 are log applied to a product,
Right.
is the sum of logs. And the other one is log applied to a ratio, which is the difference of logs.
Got you. Okay.
And this is the third one.
Oh, I see. I had earlier when I suggested that, you know, the one log minus the other could be written as division, I had it reversed.
Like my intuition was like put the 2 in the base and then put the power in the, well, actually that doesn't work. Okay, nice. Yeah, that doesn't work. Okay.
It doesn't work.
Yeah.
Very good. So of course, if you don't want to use ln, which is natural log, what is the base for natural log?
E.
Very good. You can use log. Why I would not use anything else is because many calculators don't allow you to punch in, if you want to check, they don't allow you to punch in whatever base you want. So they only have natural log, which is base E, or log, which is base 10.
So you couldn't use the change of base formula for this. Could you?
The change of base formula is for log. It's not for exponential.
Yeah, you're changing the exponential.
Very good point. Okay, let me refresh your memory on that. If I want to determine log base 3 of 5, and I don't have base 3 in my calculator, then I will have to write a ratio, or not both. One of them is log of 5 over log of the previous base, and the other one is natural log 5 of over the natural log of the previous base. But this has nothing to do with what we had. 2 raised to x minus 2 equals 3 raised to 3x plus 5.
That's an exponential.
Yes, yes, has nothing to do with that. This is just a change of base when I'm given a log in a base other than 10 or e. Because my calculator only has 10 and e as base. So I don't know what this is, but I can calculate this ratio or this ratio, and they have to be the same. Because 3 raised to whatever number I get equals 5, there is only one number that does that. Good, very good questions. Anything else here? Anything else? Okay, so let's move on and look at the next problem. We want to solve 1b or not? I'll wait for you to say yes or no.
Sounds good.
Yes? Very good. Okay, so we have log base 9 of x minus 5 and plus log base 9 of x plus 3 equals 1. My first question to myself is, again, I can give you one. I have a couple. I'll give one to AJ.
There you go.
I don't want to know, this was
This is from a long time ago. I do have, this is the last one I have. I'm so sorry.
I will not, I just forgot it.
So my first question to myself is, what type is it?
Logarithmic.
It's a log equation. Perfect. What does that mean? What does log say to us? Whenever I solve a log equation, what do I need to do?
Write it as an exponential.
Not yet. Let's think about, is log a function with restrictions or not? Because if it's a function with restrictions, I have to state the common domain first.
Oh, I think it is.
It is. So log is not a friendly function. Log cannot be applied to anything. It can be applied only to what type of numbers?
Positive.
Only positive, not zero. Correct. Good. So then for this, what do I write in order to solve and find the domain? What do I write for this to solve and find the domain? Not Tom. Anyone?
Don't you have to do x minus 5 is greater than 0,
Perfect. And for the second one?
x plus 3.
Perfect. So I have two conditions, and I'm going to put them together as x greater, I'm sorry, not equal to, x greater than 5 and x greater than -3. I am going to graph these two and make sure that I find the common domain. No units are necessary. Greater than 5, I'm going to say this is 5. And the other one, greater than -3, I only care about showing how to find the common domain. So what is the common domain?
-3 to infinity.
Common domain. Common domain means both colors. If I only have one color, it's not good. If I don't have colors at all, it's not good.
To 5 to infinity.
Indeed. 5 to infinity, both colors have to be there because one color is a domain of one and the other color is a domain of the other. And they both have to exist at the same time. Awesome. So now, what do I do with this? I establish the common domain. I have the common domain. I know where the solution should be. So what will you say we need to do? Tom already said it.
Write it as an exponential.
Right. That's my target. But I have one more step before I do that. So what do you recommend we do?
Well, on base 9, x minus 5. Plus
We just reviewed the three properties of the log.
multiply them.
Yes, but how do I write it? I'm not multiplying logs.
Yeah,
I know-
multiplying the arguments.
Yes, so log base 9 of,
X minus 5, x plus 3.
very good, equals 1. So this is one of the properties of log. Log applied to a product is the sum of logs. Now, exactly right. I will have to change it into an exponential. It's a log equation. I'm changing it into an exponential. So how do I change this into an exponential?
I want to say 9 to the first equals.
Exactly. 9 to the first power equals x minus 5 times x plus 3. That is the rule. Base raised to this number equals this number. Perfect. So now I have to work on this. What type of equation is it? It's no longer exponential. I'm sorry, it's no longer log. Is what?
Quadratic.
Perfect. So I have to distribute. X squared plus 3x minus 5x is negative 2x, and minus 15, and then minus 9 equals 0. So then x squared minus 2x minus 24 equals 0. No secrets here. This is from a long time ago. Good. So what now? What will be my next step?
Factor.
Perfect. If it takes too long, then I'll use the quadratic formula and I'm done.
-6 positive
And the two options are
6 and -4, and the restrictions are 5 to infinity.
Let's just
very good. See how important it is to write the restrictions? Otherwise, you have to go back and check. If you don't go back and check, you cannot get full credit. So please remember, it's one or the other. You can say, I don't like finding the common domain, but if I don't like to determine the common domain, I promise I'll go back and check in the original problem. So it's up to you. Very good. Any questions here? Any questions? At any point in time, if you feel that we should do another problem like this or like that, please let me know. Okay, part C. Is it a yes or a no? One C, yes or no?
I would say yes to all of them.
Very good. I just have to ask because maybe, you know, we shouldn't waste time on something we have no difficulties with, or I let you choose. I want you to choose. Good. So what type of equation is this?
exponential.
It is exponential. The variable is at the exponent level, of course. Awesome. Okay, what do I do? What is my next thought? After I identify it correctly, what is my next question? I ask myself whether,
And the bases be expressed the same.
excellent. If the 4 and 1 over 32 can be expressed with the same prime number. Perfect. So what would you think about 4? How is there a way of presenting 4 with a base that is a prime number?
2 goes 1, 8, no, -8 prime, so it's negative.
We're talking about 4.
Yeah.
I don't think you can because I'm just going through it in my head and I can't really find a negative exponent that gets you.
We're not talking about negative exponents. We're talking about what 4. Do not look at anything else. I'm only talking about 4.
What I'm trying to say is 4 raised to what power gets you 1 over
This is
3?
not what I'm saying.
Okay.
So let's start from scratch. No, that's okay. Let's start from scratch. I'm asking, is there a way of rewriting 4? Do not look at anything else. I'm only talking about 4. Is there any way of writing 4 as a power, as an exponent of a prime number? Is there a prime number that I can raise to a power to get 4?
Yes.
Which one?
2.
Right. So 4 can be replaced by 2 to which power?
2.
Awesome. So I copy the rest. Now I'm on the right-hand side and I'm asking myself, because this was written with base 2, is there a way of writing 1 over 32 with a base of 2? Correct. So there will be 2 raised to which power?
-5.
Indeed. And then I copy everything else. Okay, so one more time, I think we should go through this step. You can say, I don't want to mess with that. I want to simply apply log to both sides. Yes, you can. The answer will be the same, but you may have difficulty simplifying it at the end. So be careful with that. Now, I noticed that 4 and 1 over 32 can be presented with the same base, and that base is 2. The left-hand side, 4, is 2 squared. The right-hand side, 1 over 32, is 2 raised to -5. Although you may say that applying log is easier, it's not, because at the very end, you may have difficulty simplifying the answer. Okay? So, is this clear? Is this clear that 4 is this and this is this? We agree? Yes? Okay, perfect. So then, next step, what do? I copy the base, and what happens to the exponents?
There. Let's see.
Not Tom. So are we stuck, or can we continue?
Get rid of this 2 to the 4x minus 2.
Exactly. I have to multiply 4x minus 2 and then copy 2 and then multiply. Very good. Thank you. Negative 10 plus 5x. So whenever we raise an exponential notation to a power, we copy the base and multiply the exponents, right? We know this rule, everyone? Okay. So now, please do not say that we cancel or simplify or do anything. We are just thinking. Two numbers are equal, and they have the same base. What has to happen?
Exponents have to be equal.
Exponents have to be the same. 4x minus 2 must equal negative 10 plus 5x. Awesome. That's the correct answer. And now this is what type of equation and how do I solve it?
Linear.
Correct. Very good. So I'm moving 5x to the other side to get negative x, and I'm moving negative 2 to the other side and get negative 8 because I'm adding 2. So finally, x equals? Very good. You can go back and check if you want to. Any questions? Any questions? Okay, so let's move on. This is not part of this test. It was part of the previous test. This is not part of this test. It was part of the previous test. So find the domain of this function. Yes. So we have f of x equals log of 2 minus x. How do I find the domain of this function? What do I have to write? Anyone? We just wrote this 5 minutes ago. Say it again.
Greater than 0.
What?
2 minus x.
Very good. Awesome. So then we have negative x greater than negative 2, and then?
X is less than 2.
Awesome. So then the domain of function f, can anyone dictate it in interval notation?
Negative infinity 2 parentheses.
Very good. Perfect. Log cannot be applied to negative numbers. Very good. Any questions on this problem? And this is it. That's all we are asked to do. Find the domain. Okay, next one, problem 4. Graph the function using transformations. Present transformations, the transformations in order of operations. Find x and y intercepts algebraically. Graph the asymptotes, if any. Find the domain and range. And this is the function. So f of x equals negative 2 raised to x minus 3 plus 4. Any suggestions, any steps that you can think of, anything?
To graph it.
Yes, using transformations.
Horizontal translation.
So what do I have to write first?
The base function.
Awesome. Excellent. I need to identify the base function. The core function, exactly. Very good. Awesome. The core function that was used to create this function. Very good. Then I have to identify the first step, and they have to be in order of operations. What will be the first step?
Order of left?
How did we?
I don't remember exactly which one goes first. But
The order of operations means
no. I get that with like an equation. It's just with this I sort of forgot.
just imagine that you are evaluating for some x that you think of. What operation will you perform first? If x is 15.
Exponents.
Correct.
So
So what is the first
down
transformation?
3.
No. When we
Oh.
change x, we don't go up and down.
Okay.
Horizontal.
Very good.
Right 3.
So what do I write? What is the first transformation then? On 2 to the x.
3 to the right.
2 to the x minus
Very good. 2 to x minus 3. So write 3. Awesome. Function number 2 is the transformation on function number 1.
Flip about.
Very good.
Y-axis.
Negative 2, x minus 3 reflect with respect to the x-axis. Very good. Awesome. And transformation 3 is on transformation 2, on function from 2.
Negative 2x. Negative 2 to the x minus 3 plus 4. Yeah, up 4.
Very good. Awesome. Good. So I will present these transformations. First, the base function. How do I graph the base function? How do I graph 2 to the x?
No, 1 point crosses through.
Which
0,
is?
1.
Correct. Is it increasing? Awesome. Is it increasing and going through that point, or decreasing and going through that point?
It's increasing. Those
Yes.
1.
Why? Because the base is greater than 1. Awesome. Okay. Very good. So here's the graph of 2 to the x. Indeed, it passes through 0, 1. So this is 2 to the x. Perfect. We are moving this graph first, as you said correctly, moving it right through it. Perfect. So this point, that is quite important now, will be shifting. I will be shifting it where? You already said that. Just one more time.
Right 3.
So this point moves here. So this is the graph of 2 to x minus 3. Then you told me to do what to this graph?
Reflect about the y-axis.
About the x-axis.
Oh.
So now where does this point go? So it's now at 3, 1. Where will it
3,
go?
-1.
Very good. Awesome. So here is the graph of -2 raised to x minus 3. Perfect. And now the final step, you said?
Up 4.
Up 4. But remember, all these 3 functions have a horizontal asymptote, which is
0.
y equals 0, not 0,
Yeah.
y equals 0.
This
When I shift this yellow graph up 4, where will
y
this?
equals 4.
Exactly. I have to shift the horizontal asymptote first. So now it's at y equals 4. And just tell me, where will this point go? This point will go 3, 3, 3 indeed. It will go to 3, 3. So this is the final graph. You don't have to do this. I just want to make sure that since I have 4 different graphs in there, we understand which one is the final function. So this is f of x equals -2 raised to x minus 3 plus 4. Very good. Now, one of the questions was asking us to identify the domain. Can anyone give us a domain of this function?
All real numbers.
Very good. Can anyone give us the range of this function?
-infinity to 4.
Very good. Perfect. Now I would like to find the x-intercept or the x-intercepts. Well, obviously, how many x-intercepts can it have? 1. Good. How do I determine the x-intercepts for any function?
I get y is 0.
Set y equal to 0. Very good. Which is -2 raised to x minus 3 plus 4 equals 0. Awesome. What type of equation is this, and how do I solve it? It is exponential. Awesome. How do I proceed?
I'd like to get that 4.
Of course you have to. These steps I call cleaning it up.
For logarithms.
Exactly.
Exponentials.
Yes. For whatever I'm doing, I have to clean it up. Okay, what else do I have to clean up?
0 and positive.
Yes, multiply both sides by -1. Of course, I refuse to solve something like this when I can make it simple. Good.
So 2 to the 4th power equals x minus 3.
Why 2 to the 4th power?
Oh, no, wait.
So the left-hand side is 2 to x minus
Side,
3.
sorry,
That's okay. The right-hand side, I mean, we already know what 4 is. We shouldn't even think, right? What is 4? I'm looking on the left-hand side,
3 over the 2.
right? I'm trying to present both sides with the same base. This was the problem that we just did, right?
X minus 3 equals 2.
I'm trying to present both sides with the same base so I can make it as simple as possible. Good. Okay, so then two numbers are equal and they have the same base. What must happen here?
X minus 2 equal.
Okay, so what do I have to write?
X minus 3 equals 2.
Good, which means x equals?
5.
Good. What is the ordered pair that represents the x-intercept?
5, 0.
Awesome. Here it is. 5, 0. This is 3, this is 4. I'm close. Not perfect. I wasn't expecting to have a perfect graph anyway. Okay, now I want to find the y-intercept. How do I find the y-intercept? For any function.
Set x to 0.
Very good. So I have to find f of 0. So it's negative 2 raised to 0 minus 3 and plus 4. Good. Good. So yes, I have negative 2 raised to negative 3 plus 4. How do I proceed?
Negative
Yes?
2.
No?
No, negative 1 over 8.
Very good. I completely agree with that. So negative 2 to negative 3 is 1 over 8 with minus in front is negative 1 over 8 plus 4. And now I have to find the least common denominator so I can add these. What is the least common denominator? Very good. So then this one needs an 8. This one has a negative 1 and this is very good. So then the answer is 31 over 8. Can anyone give us the ordered pair that represents the y-intercept?
0, 31, 8.
So here it is, right here. This is 0, 31 over 8. Almost 4, of course. 31 over 8. It's not too far from 4. Very good. Awesome. Any questions on this problem?
How did you determine
Yes.
the base was 2x?
No, the base is not 2x.
That's-
There is no base 2x.
I think she means
Base graph.
So you're talking about 2 raised to the x.
Can you go back to the page before?
Sure, yes. We're not talking about a product.
2 to x. Okay.
We're not talking about the product, right? We're talking about an exponential function. If I write 2x, I'm not talking about an exponential function.
I wrote 2x.
That's okay. Better?
Yes.
Because it's exponential. So I cannot, there is no 2 times x in here. Very good. Perfect. Other questions, please? Anything else? It's easier to clarify everything here than you when you get home and start digging up stuff. So please. Okay, do we need to do 5? We had a similar problem in class, but if you say we need to do this, so we will do it now. Yes? Is it? Okay, very good. So we have a function. We are given f of t equals 500,000 divided by 1 plus 2,499 e to negative 0.92 t. Okay. Models the number of people. I take notes when I write, when I read something. It's number of people. In a city who have become ill with the flu, T weeks after its initial outbreak. T is in weeks. Very good. How many people became ill with the flu when the epidemic began?
I want to say 2,500. Because 1 plus 2,500.
Before we look at the function, how do we determine that?
T0.
Yes, so I have to find f of 0. We will in a minute. Part B. How many people were ill by the end of the 6th week? F of 6. We'll come back to that in a minute. And final question, what is the limiting size of the population that can get ill?
500,000.
Correct. So in other words, this means when t increases without bound, where will f of t go?
500,000.
So correct. So all these 3 questions will be answered with a graphing calculator. So let's take a look. So in y equals, please put in this function. So 500,000 divided by, in parentheses, 1 plus 2499 times e raised to, don't forget parentheses,
Negative.
negative 0.92x, close the parenthesis for the power, and don't forget to close the parenthesis for the denominator. Very important. So now we go to second and table, and we plug in what we want. Okay. So I think we did this problem last time. So 0, 200, 6, or I had some numbers in here and then it calculated right away. For 6, okay. Let's say 40 weeks, which I already have, and let's say 80 weeks, which I already have. Not 40, 80, but anyway, 100, and so on and so forth. So all I have to do is just copy these numbers. 200 people got ill initially. Then in 6 weeks, 45,411 people. And then as time went by, maximum 500,000 people. Cannot be more than that. So this is a rational function combined with an exponential, but still a rational at the core. So what does this mean? When we are told that as t increases without bound, t goes to infinity, the function values approach 500,000. What does this mean? Thank you very much. Yes. Is the horizontal asymptote of this function. Yes. Very good. Awesome. Any questions on number 5? Okay, let's move on.
The domain is like 0 to infinity.
The domain of this function is 0 to infinity. Yes. This is not part of this class. I'm sorry, of this test. Moving on to number 7. We're asked to expand this expression into simple logs. And that's my page 6. So we are given log base 2. At the top, x times the square root of x minus 1. In the denominator, 3x plus 4. Did I jump on something or over? Did I do something? Okay, so, and the next one on number 8 is not part of this test. It was part of the previous test. Okay, so how do I expand this? Where is my starting point?
Getting rid of the fraction bar.
The first step is the fraction. Very good. And what do I write?
Log base 2 of x times root of x minus 1
Very good.
minus
Awesome.
log base 2 to 3x plus 4.
Very good. Perfect. Okay, what next?
I think you can get rid of that radical.
First of all, I have a product. Before I even look at the radical, I have a product of these two quantities. How do I proceed?
X times x minus 1. X times root of x minus 1.
Log base 2 of x.
Log base 2 of x.
Log base 2 of square root of x minus 1.
What do I write here?
Plus.
Aha. Log base 2 of the square root of x minus 1 and minus log base 2 of 3x plus 4. Awesome. I have one more step. Not on this and not on this, but on this.
As I said, 1/2.
Very good. So the square root is power 1/2 that goes in front as a factor. Log base 2 of x plus 1/2 log base 2 of x minus 1 minus log base 2 of 3x plus 4, and this is done. We cannot do anything else. We have no property of log applied to a difference. Do not attempt to simplify this in any way, shape, or form. We have no log applied to a sum. You cannot, there is no property for log applied to a sum. There are only 3 properties. Log applied to a product, to a ratio, or a power. This is it. Moving on. Any questions on this problem? Any questions? Okay. So this function f of x, I'm going to copy it. equals 80e to negative 0.5x plus 20. Describes the percentage of information. So this is a percentage, f of x, that a particular person remembers x weeks after learning the information. Find the percentage of information remembered at the moment it is first learned. Part A. In part B, after 1 week. In part C, after 4 weeks. In part D, after 52 weeks. So what am I asked to find in A, B, C, D? And then we'll look at E.
F of 0,
Yes? In the next one?
F of 1,
Yes?
F of 4,
F of 4?
F of 52.
Very good. So let's put in the function in the graphing calculator. Careful how you put it in. 80 multiplied by E. Do not forget parentheses. Negative 0.5 x. Close the parenthesis for the power. And come down from there from the power plus 20. Any questions so far? Okay, in that case, we go back to second and table. And I will put in the numbers that Tom dictated to me. He said 0, okay, 100%. And then he said 1, enter. Then he said 4, enter. And then he said 52, enter. Happy? Okay, so 100%, 68.5, 30.8, and 20%.
So when you're on the table there,
Yes?
how do you get the x to change?
You have to go to table set, and you have to change the independent variable into
Table set.
the independent variable has to be in the ask mode. Because if it's not in the ask mode, you cannot punch in whatever you want. Yes, and now you will be able to.
Thank you.
My pleasure. Second and table, and punch in whatever you need. So we had 0, we had 1, we had 4, and 52. Other questions? Dallas, is this okay now?
Well, actually, there's part E, isn't there?
Yeah. No. I'm just, I don't have room here, so I have to move on to the next page. Of course. No, I will not forget part E. Okay, after how many weeks does the percentage drop to 50%? Oh, I'm sorry. So after how many weeks will the percentage of the information retained drops to 50%? What am I asked to do, and how do I do it?
50 equals.
Correct. Very good. Now we are given the y value. 80e to negative 0.5x plus 20. Very good. Okay, perfect. What is it? How do I clean it up?
Exponential.
It is exponential. How do I clean it?
20 over.
Very good. Perfect. It's not cleaned up yet. I have one more step in order to clean it up.
Write it as a log.
Divide
Both.
E to get E by.
Very good. 3 divided by 8. Now it's completely cleaned up and ready. Ready for what?
Be written as a log, like I said.
No, apply log to both sides. Which one? So I can make my life easier if
Natural
I,
log.
yes, because of E here. Very good. So natural log of 3 over 8 equals negative 0.5x times natural log E. How much is, very good. Natural log E is 1. So then from here, what do I do to both sides to get x by itself, because that's my target? How many weeks will pass till the information that I originally had 100% in my mind, it dropped to 50%? So what do I have to do? Divide both sides by? Of course. I just want you to say it. Yes, of course. So let's go in here and go to second and quit. Clear if you want. And then I plug in natural log, parentheses 3 divided by 8. Don't forget to close the parenthesis. And then divide in parentheses, please, by negative 0.5. And 1.96.
Hey, an irrational number.
What does 1.96 mean?
That's how many weeks?
Yes, approximately 2 weeks.
So 2 weeks you can get half.
Yep. Yep. I hope
Sounds
that's
about right.
I hope that's not the case with you in this class.
Yeah.
The extra credit is not part of this. The extra credit is not part of this test. So this is the last problem in this test. So let's read it and see what it's asking us to do. So when I read a problem, I take notes. In the year 2000, it says the population of Israel was approximately 6.04 million. And by 2050, it's projected to grow to 10. Use the exponential growth model. This is what your book shows. This is what I recommend. It doesn't matter. Use the one you like. This is the popular one because we're talking about a number, but it doesn't matter. It's the same thing. To find an exponential function that models the data. Okay. So this is the function. There is nothing I can do to it. And this is the independent variable. There is nothing I can do to it. I'm missing the original and I'm missing the growth rate. Once I have the original number of people and I have the growth rate, then the model is completely known. There are no more secrets. So what is given in this problem?
The population as of 2000.
Okay, and what does that mean?
I believe that's the initial amount, 6.04 million.
Actually, the problem is telling us that t is the number of years since 2000.
And
So
6.04 million is when it is.
So the year
right on
2000 means 0 years.
When t is 0.
Exactly. Exactly. That's all I wanted you to say. We are given an ordered pair, which is in this case 0, 6.04. Okay. What else are we given here? So this is the information coming from this piece. What else is given to us?
10.
Say it again.
50.
50, 10. Awesome. Because this is another ordered pair. Perfect. Answer 50 years after 2000, which means t equals 50, and t has to be the independent variable. Time is always the first variable, the independent one. And 10 million number of people. Awesome. Good. So let's use now the first ordered pair, which you already did, but we have to write it down and explain what we just did. So the first ordered pair says what to us? So I would like you to tell me how to plug in this ordered pair in the model. Just dictate.
A at 0 is 6.0. Oh, wait.
What is this in this ordered pair? What is this? Which of these two variables is this?
0.
No. If it's not 0, then it's the number of people, right? This is the number of people, 6.04. Equals A0 times E to what? K is K, I don't have it. But what is T?
K times 0.
Yes. Indeed. So how much is K times 0?
0.
How much is E to 0?
1.
1. How much is 1 times A0? So this is how we get A0. Yes, intuitively you already told me, but this is the way we present it.
I blurted out 0 because I forgot that anything to the 0 is not 0 but 1.
But 1. Correct.
Even I.
That's fine. So now I already have the A0. I can go back to the model. A of t equals 6.04 times e to kt. This is what I have so far. I determined the initial population. Now, please tell me how to plug in this point in the model. Please dictate when you're ready.
A of 10?
Yes, how much is A of, no, not A of 10, sorry. I spoke too soon. Not A of 10.
A of 15?
Yes. But how much is it? I want to replace it directly.
A of 50 equals
Yes? How much?
10e.
10. A of 50 equals 10.
Just 10.
Counterintuitive because the last one was like.
A of 0 equals 6.04. A of 50 equals 10. We know this, right? This is how we read functions, right? So when we are given an ordered pair, if I tell you 1, 2, I mean f of 1 is 2, right? So when x is 1, y is 2. Same thing here. When x is 0, y is 6.04. When x is 50, y is 10. So that's why the left-hand side here is 10, and the right-hand side is this, times e to which power? Say it again.
K times.
Yes. K times, yes. Good.
50.
Exactly. If I plugged in 10 here, I have to plug in 50 here. Because they have to come from the same ordered pair. I'm not sure this is clear. Let's review this. Which part is not clear? Because I'm not sure you are convinced. Maybe I didn't manage to convince you. Maybe I should say more about this. So any ordered pair on a function, on the graph or that verifies a function, is clearly A of 0 is this. So if I have 1, 2, then f of 1 is 2. If I have 50, 10, I have A of 50 equals 10. So A of 50, which is this, which is 10, equals 6.04 times e to k, which I don't have, times t, which is 50. So when I plug in 50, 10 in this expression, I get this. Is that clear? Better? Anyone? Any questions? Okay, what am I solving now for?
Okay.
Correct. What type of equation is it?
Exponential.
Good. How do I clean it up?
Divide both sides by 6.04.
Good. What now?
Natural log.
Very good. So natural log 10 divided by 6.04 equals?
Natural log. 50.
Very good. Times natural log e. But natural log e is
It's 1.
1. Very good. So then k will equal? Awesome. Well done. So let's plug it in. So in natural log of 10 divided by 6.04 and everything divided by 50. So I got k. Don't forget 4 digits. K is approximately 0.0101. I made the 5th digit, I made it rounded, yes. So finally, we have the entire model. So we have that A of t equals 6.04 times e to 0.0101 t. And we're ready to answer part B. Find the year in which Israel's population will reach 8 million, assuming the model still holds. We don't know that, but For now, let's assume that the model still holds.
Before we go on, can we just go back to the ordered pair you had?
Yes,
Okay, so the first variable, I mean, which is the x value, right?
yes, and that's always time.
That is always going to be time
Because
because
time
an
is independent.
variable,
Correct.
meaning it's always changing.
No, it means
I
that
mean,
it
meaning-
does not depend on
Oh,
anything.
gotcha. Yeah, okay.
So
So like the x variable.
the x variable, if time is involved,
Right.
time is always independent.
Gotcha. And then the y is
The number
the
of people that
output.
depends on time.
Okay, gotcha. What you get from putting in that first x value. Okay.
Yes,
Okay.
because 2000 represents t equals 0. That's how we get this ordered pair, 0, 6.04.
Gotcha.
Because 2050 is 50 years after 2000, that's the first variable, the first coordinate, 50. And the y coordinate is the 10 million.
So f of 10 equals 50.
No, the other way around. F of
equals-
50 equals 10. I cannot plug this in because this is not the x.
It's the y. You
It's
need
the
the
y.
x before you have the y.
Correct.
Okay. It's just
So,
when you put it like that, I just got confused, but now I get it.
so 50, 10 means f of 50
Right.
equals
You
10.
will always start with the x value.
Because that's what I plug in.
And then
In
the
y, I
is-
cannot plug in
is
y.
dependent on the x. Okay.
In y, or in the function, I plug in x.
Thank you.
Is that better?
A lot better, yeah.
Anyone else? Do we have any doubts on this or any questions on this? Okay, final question here. This problem is asking us to find when will the population reach 8 million?
F of 8
Yes?
equals 6.04 e to
So what is this? What do I have to write?
just have to plug in 8
For what?
for e.
No.
Oh.
8 is not time. 8 million
Is the-
people.
8 is the y.
Exactly. So what do I write?
8 equals
Yes. Very good. Indeed. Because we are trying to find when it's supposed to reach 8 million. So now the ordered pair is t comma 8. And t I don't have. Good. So now again, I'm asking myself, what type of equation is this? And the answer is?
exponential.
Good. Is it cleaned up?
No,
No. So what do I need to do?
divide both sides by 6.04.
Okay, next.
Natural log.
Indeed.
Natural log of 8 over 6.04 equals 0.0101 t.
Perfect. And finally, how do I get t?
Divide by 0.0101,
Not t.
not t.
Good. Because I can solve if I divide by t. Good. So let's do this. So we have natural log 8 divided by 6.04 close and divide by, oh, I'm just going to copy the previous answer. Because I have it. So roughly 28. What?
Years.
Yes. Which means which year exactly?
2027.
Good. 27, 28, something like this. Assuming the model still holds. But we don't know that. Any questions?
So 28, 8.
It's 27 point something, so it's roughly 28 years. Okay. Let's take a look at this one. I gave this one out some time ago, together with the other, with the green and the orange. We can only look at the first 2 pages, 4 pages if you want, back and front and back. So only the first 2. The rest, the last 2 pages are not pertaining to this. I just brought everything I had. Now,